Hello, everybody, and welcome to Navigation in Multi-Module Projects and the problem with AndroidX Navigation. Before we get started, I thought I'd better introduce myself. My name's Isaac Indy. I am an Android developer at Xero, and I work on our mobile platform team, building SDKs and tooling for our mobile product teams. I'm really interested in large projects and large teams and how engineering, architecture, and strategy can enable those teams to grow effectively. I also maintain a library named Enro, which is an alternative to AndroidX Navigation. So feel free to take that as a bit of a bias warning for this talk. And what am I talking about today? Well, I'm going to be covering a few different things, of course, all focused around navigation in multi-module projects. I'm going to start off with a quick recap on what I mean when I'm talking about multi-module projects, an overview of why I'm interested in navigation and why I think you should be interested too. A look at a few different ways that you can use AndroidX Navigation in a multi-module project and why I don't like any of those approaches. And finally, we'll have a look at what, in my opinion, is a better way to think about and work with navigation in multi-module projects. So, what do I mean when I say multi-module? Well, I'm talking about reasonably large projects that are split out into multiple feature modules, just regular Android library modules, not dynamic feature modules. The goal being here that different teams can own different modules independently. These feature modules can't depend on each other directly because we want to avoid circular dependency issues. And of course, we want to compile our modules in parallel so that we've got nice fast builds. This diagram shows what I mean. So dependencies flow downwards from the application to the feature modules, and then flow down into a core module. In real life, your core might be split apart, or there might be a few more layers in between, but this structure is a simplified example that we can use to discuss some problems. So, why do I think navigation is interesting? Well, on Android, we've got quite a few different constraints around how navigation works. We don't get to call the constructors for our screens. The arguments to our screens are just bags of strings pointing at objects. And of course, the Android lifecycle causes some interesting problems. Activities die, applications die, and we need to support everything being recreated nicely after configuration changes and after an application process death. All of these constraints don't make navigation fun, but constraints like this, at least to me, make the problem interesting. Because of these constraints, there are a lot of different approaches and opinions on how to tackle navigation. We've got activities, fragments, and views all being used to represent screens in an application. And in the not too distant future, we'll be adding composable functions to that list. We often use intent or fragment factories attached to an activity or fragment companion object to try and get a little bit more control over the bag of strings that makes up our arguments. We can use deep linking to navigate between screens from both inside and outside of our application. Some people like to use dedicated navigator classes with injected activities or fragments to sort of centralize their navigation logic. And there's a whole heap of different ways to handle results from screens, from activity result contracts to shared view models, global event buses, and more. Unfortunately, we won't really have a lot of time today, so we're not going to cover results in as much depth as I would like to. But I want to call this out as something I think is a really important part of navigation that often isn't done well. And of course, navigation is important for multi-module projects. When you're working across multiple teams, it's important to use a consistent strategy, particularly at the points of integration between teams, because these are the hot spots for conflict. So you want to be doing the same thing when you navigate to a feature owned by team A as when you navigate to a feature owned by Team B. But at the same time, you still want some flexibility on how you do things internally. You don't want too many rules to follow, or that consistent strategy will start slowing you down. Finally, multi-module means, at least as I have described it, that you shouldn't be using direct class references. So that kind of rules out those simple intent or fragment factory methods attached to companion objects, because we just don't have those classes on our class path. This means we need to look at a more complex strategy. And finding the right strategy that balances the constraints, creates a single approach, and works well in a multi-module project, well, I think it's a very interesting challenge. Luckily, Google has solved this for us, right? We have AndroidX Navigation. So a quick recap on what is AndroidX Navigation. Well, it describes itself as a framework for navigating between destinations within an activity, within an Android application, that provides a consistent API where the destinations are implemented as fragments, activities, or other components. Despite being able to navigate to all of those different component types, AndroidX Navigation does focus on fragments as the primary screen type. Because of this, I'm going to say fragment a lot for the rest of this talk. But when I say fragment, you can take that to mean fragment activity or other component. It's just a little bit easier to say fragment. AndroidX Navigation is based around the concept of a navigation graph, which is an XML resource file that contains information about navigation destinations, fragments and activities, the arguments to those destinations, as well as definitions of actions, which allow you to navigate from one destination to another. And these actions can be globally scoped or scoped to a specific destination. Because of this, you no longer need a direct class reference when you're performing the navigation, only a reference to the navigation group. AndroidX Navigation also comes with a Gradle plugin called SafeArcs, which will generate navigation destination classes that represent your destinations and their arguments. These are then used to perform navigation, providing a little more type safety both when navigating and when reading arguments from a screen that has been navigated to. This little diagram here is a bit of a simplified example, but it helps me kind of think about how this works with SafeArcs. The navigation graph creates the navigation destinations, which points to fragments, and when you want to navigate, you use the graph and the destination to perform the navigation, which is then resolved to the fragment that you want to navigate to. This all sounds great for a multi-module project. We don't need direct class references to navigate, and we've got SafeArcs to help keep our arguments consistent. But how does it work with multiple modules? Well, there are several approaches for using AndroidX Navigation in a multi-module project. You can use deep links for everything, use ID resources defined in a shared module, or define a whole navigation graph in a shared module. There are probably more than just these three ways of doing things, but I haven't found any other notable ones. If you have though and think I'm missing something, please let me know, because I would love to add another item to this list. We're going to dive into some code examples of how these three options work, just at a pretty basic level. But first, let's have a quick look at the module structure I would like you to imagine when we're looking at these examples. So it's going to look a little bit like this. It's a super simple example project. We've got one application module, two feature modules, and one core module. We'll imagine that each feature module contains a fragment, feature one fragment and feature two fragment respectively. And we'll also assume that feature one fragment and feature two fragment each need to navigate to the other. So the modules can't actually depend on each other, because that would be a cyclic dependency. So we're also going to imagine that the application module sets up all of the boilerplate activity with an post fragment and all of this kind of AndroidX Navigation boilerplate that we would need to get this working. We're just going to take a look at some sort of quite minimal examples of navigation graphs and a little bit at how it works in the fragments to actually perform navigation. So let's start by taking a look at deep links. Using the deep link strategy, we're going to place a navigation graph in each of our feature modules and one in our application module. The feature modules will use deep link URIs to perform the navigation, and we'll be able to use safe args to read their arguments out. So we start off by adding a navigation graph to one of our feature modules, which is going to look a little bit like this. So this is our feature 1 navigation graph. We can see we're defining a fragment destination there called destination feature 1. And that's going to have 2 arguments, a string and an int. And underneath those arguments, we add a deep link item, which provides a URI with some path placeholders for our arguments. Once we've got this navigation graph, and we've got a similar one for our feature 2 and feature 2 fragment, we can define a navigation graph in our application module. And that's going to look a little bit like this. It's basically just including the other graphs from our feature modules. Nothing complicated here, just merging everything together to be used. Now that we've got our feature level graphs and our application level graph, let's look at how we actually perform navigation from a fragment. Well, in the feature 1 fragment here, we can see we can use the safe args generated arguments for feature 1 fragment and the by navargs extension to read the arguments for the fragment in a type safe way. And when on button clicked is called, we can parse a URI from a string and use that to perform some navigation. Pretty straightforward. So what's good and bad about this solution? Well, on the good side, we can use safe args in the fragments to read arguments in a type-safe way. Using this solution means that the application is well set up to support external deep linking as well. On the bad side, we're limited to using simple types that can be serialized into a URI and can't really use more complex or nested objects. Because we're essentially just using strings to perform navigation, it means that we don't have good find usages support to actually find out where these screens are being used and being navigated to. And that means that refactoring can be slightly unsafe. If you wanted to add or remove an argument, you're going to be searching for strings all throughout your project to update. And if you miss one, it's going to be a runtime crash. This can be mitigated, though, through some creative coding. Perhaps you could add a deep link builder or something to the core module, which would be able to build these deep link URIs in a more type-safe way in a sort of centralized place. But that's getting into custom tooling on top of AndroidX Navigation, so we won't go into that too much. All right. Our next option is the bottom IDs strategy, which, as suggested by the name, this strategy means that we're going to have some resource IDs defined at the bottom of our module structure in the core module. And then we will also add a navigation graph to the top level application module. In our features, we can then use these shared resource IDs to perform navigation. So the first thing that we do is in our core module, we create a resource file and define some shared resource IDs, which is rather novel. I don't think many people actually go out and define IDs manually. Most of the time, at least in my experience, just at plus ID is enough for what I'm doing. But we need to do this because we're going to be using these ID definitions for some actions that we're going to define in our navigation graph. And that navigation graph is going to live in the application module and look a little bit like this. So this navigation graph is going to define the whole navigation graph for our application, and then use those IDs from the previous slide as the IDs for some actions we're defining. So we can see here we've got our familiar fragment destination for feature 1 fragment with those arguments, and we're then underneath that defining an action reusing the open feature 1 ID we defined in the core module, which is pointing at the destination feature 1 there. Now, it's possible to use included or nested navigation graphs here, but in general, the top level or shared global actions still mostly need to be defined in the application level navigation graph. Okay, now that we've got all of our XML set up, what does this look like inside of our fragment? Well, because our fragment's destination is defined in the application module's navigation graph, our feature module doesn't actually have access to the generated safeargs object. So we've got to fall back to using regular fragment arguments and pulling data out of the arguments bundle. Not so nice. When we actually want to perform some navigation, we can use one of the IDs that we have defined in the core module. You can see that there with navigate to ID open feature 2. But the arguments for that screen, we're going to be having to pass that through as a bundle. Again, because we don't have access to the safeargs generated classes. Overall, it's a bit of a different solution to using deep links. It's great that we can use more complex objects. We can throw any pass level we like into our arguments. But that's really the only upside I see with this solution. We don't get to use safeargs using this solution, at least not in the way that I've described it. And while it is possible to get safeargs sort of halfway working, like in the deep linking example, we need to start using included graphs, which can become quite tricky due to the way the action scoping works between included graphs. So the final option we have is using a bottom graph. And in much the same way as bottom IDs means we're going to put some IDs at the bottom in our core module. For this strategy, we're going to put a full navigation graph in our core module. So this is going to generate the safeargs destinations for us, which we can use to perform navigation in our features. So we start off by defining the full navigation graph in the core module, which you might be thinking seems like it shouldn't work because the core module doesn't know about either of our fragments. The IDE will highlight these references as errors, but I can promise you this does actually work. You obviously won't get autocomplete when you're writing this navigation graph, but this option is probably the closest to what you'd be used to if you had used AndroidX Navigation in a single module project before. So once we've added this navigation graph with all of its broken references, there's no other steps we really need to take other than starting to use this in our feature modules. So what does that look like? Well, if we come back to feature 1 fragment, we can use safeargs to their fullest extent. We can read our arguments in using the by_navargs extension. And when we want to navigate out, you'll see there that we can use the core navigation directions open feature 2 to open feature 2. So, pluses and minuses for this solution? Well, it's great that we're able to fully use safeargs navigation, and it's very close to what you'd do in a single module application, which makes it quite easy to get started with. On the other hand, I am sort of left wondering whether or not this should actually be possible. It works, but it does feel like something that could be broken by a new version of the library in the future. This solution also brings up some concerns for me around refactoring as well. If you're moving files around in packages or renaming packages, you need to remember to manually update the navigation graph or you'll end up with runtime crashes. So now that we've seen all of these options, we can start to stack them up against each other. I'm not really a big fan of using shared ID resources, as I think this gets complex pretty quickly, especially if you're using included graphs. The deep link solution is quite workable, but can pose challenges if you need to send more complex objects as part of your arguments. This may particularly be a problem if you're trying to migrate an existing application that relies on complex or nested objects into a modularized application using AndroidX Navigation. The bottom graph solution is quite nice to use once the graph is set up, but is, as long as you're not doing too much package moving or renaming. But the navigation graph itself can get pretty huge, like hundreds or thousands of lines long, as that's the centralized place where all your screens are defined. And this means it can be pretty difficult to edit if you've got a large project, and becomes a little bit of a hotspot for merge conflicts. So each of these approaches has its own downsides and advantages to balance, but it's also interesting to talk about the common problems with AndroidX Navigation. So the number of approaches itself is a big one for me. As we've seen, there are at least 3 different ways to get things working in a multi-module project. And this isn't great for ensuring consistency, especially in large teams. Even if you try and stick with one option, the other options still exist, and you're likely to end up with a mixture of approaches, which will make your navigation a bit of a mess and difficult to maintain. The number of options also makes it a little hard to find clear information about exactly what you might need to do. Sometimes things that would work in one solution won't work in another. For example, nested graphs work very easily with the deep linking solution, but using shared resource IDs, you can run into trouble with scoping on actions in the nested graphs. I'm also going to call XML a problem here, not because there's anything inherently wrong or unstable with XML. It's just that I don't really like writing XML. I don't think it's a very fun developer experience. And finally, results. The recommended way of sending results back from a screen is to reach into the state handle for the previous screen and then just kind of put some stuff in that save state handle. This means that when you open a screen, you now also need to know the name and type of the results that that screen might try and send back to you, which is not defined anywhere in the navigation graph. And you sort of have to read the fragment implementation to figure out exactly how it's going to do it. But, this is a well-supported library, so maybe these problems could be fixed in the future. Well, I'm not so sure about that because of what I see as the core problem with AndroidX Navigation. So what's the core problem? Well, a little snippet from a navigation graph that very similar to what we would have had in the examples earlier. I have a fragment. That fragment is defining a couple of arguments. And it doesn't really matter if it is a fragment activity or some other component. The most important thing here is that the component owns the arguments. So another way of looking at this is a little bit like this. The fragment defines its set of arguments, and the set of arguments form an input contract for that screen. Those safe args generated navigation destinations are just representations of the input contract for a particular destination. The fragment owns the input contract with AndroidX Navigation, and that means the contract has to live in a module that knows about the fragment, which is going to either be the module the fragment is defined in, or the application module, or I suppose the core module if you're happy to put up with broken references filling your navigation graph. But essentially what this means is that we can't really move the input contract into a module that doesn't know about the fragment in a nice way, which is what we would really want to do in a multi-module project. So what's the alternative to this? Well, Start thinking about the input contract as something separate to the fragment, something that comes before the fragment. Perhaps you would even start writing the input contract before you've started building the fragment. It should be a contract that the fragment fulfills, not a contract that the fragment defines. When you start doing this, it means you can extract the contracts for your screens out into a common module. That means a screen can know not only about the contract that it fulfills, but about the other contracts that can be used for navigation. So how do you actually approach this? What are the approaches here? Well, unfortunately, you're probably going to need to write a bit of code yourself to make this work, or depend on a third-party library. But that being said, I don't think this should scare you away. Because XML is so verbose, in some cases, you'll end up with less lines of Kotlin code building a solution yourself when you compare that to the number of lines of XML you'd have had to have written to use AndroidX Navigation. So there are lots of different ways to go about this, mostly limited by your imagination, but there are a few general approaches that are worth talking about. We don't have much time to go into depth on each of these approaches, but I've got some small code snippets to sort of spark your interest and get you thinking about how this might work. Let's start with activity result contracts. So activity result contracts were a new feature of AndroidX Activity, released earlier this year. An activity result contract defines an input and an output type in a generic way, and you implement the activity result contract and then override a few methods to create an intent or parse a result. One way of using these in a multi-module project would be to define an interface in your core module, like I have there with the interface navigation contracts. You then define the actual implementations of these varied activity result contracts in your feature modules, and then implement the navigation contracts interface in your application module, using the activity result contracts from your feature modules as the objects that will be returned from these functions here. You then would be able to provide binding for this interface through dependency injection or similar, and request that in your feature modules. Obviously, this solution only works if you're willing to use activities for most of your screens. But even if you're not a big fan of activities, activity result contract is worth taking a look at, as it's one of the only options that will treat results from screens as a primary concern. I also think it's got a really interesting API, which tackles some of those configuration change and application process depth constraints quite well, and it's certainly inspired some of the work that I have done. Next up, we've got navigator interfaces, which is a pretty simple solution, although it can end up being quite verbose. Essentially, your core module defines a set of interfaces, one for each screen that you might want to navigate to. Each feature module then implements one or more of these interfaces and uses dependency injection to retrieve the interfaces that it needs to actually perform navigation. So you can imagine that the feature one module would implement and provide an implementation for feature one navigator, and the feature one fragment would ask for feature two navigator to be injected into it, and then it would be able to use that to perform navigation. With Hilt making Dagger really easy to use in a multi-module project with the app installing functionality, this option is much easier to set up now than it would have been a year or two ago. Just a lot less boilerplate to write. So this is quite an interesting one. It's definitely worth exploring. Handwritten safeguards. Well, this is pretty close to what it sounds like. We're just going to kind of take some inspiration from how safeguards works in AndroidX Navigation, but write the implementation ourselves by hand. To do this in its most simple form, you'll need two interfaces in the core module, and then a bunch of pass-level data classes that represent your screens and your arguments. Essentially, in your feature modules, you can expect one of these navigation key objects to be passed in as one of the arguments that you can read out, So for example, feature one fragment would expect that there is a feature one screen in its arguments bundle. Then in the application module, you need to implement the navigation controller and use a big when statement and switch functionality based on the type of the navigation key that you pass in. So when key is feature one screen, start a fragment transaction to open the feature one fragment. Of course, you can get a little bit more complex with this and kind of combine this solution with navigator interfaces to have to avoid having that big when statement, but that's getting into more complex implementations. And your final option, of course, you could depend on a third-party library to do some navigation in your application. There's actually no hugely popular third-party options out there, and what is out there is mostly varying implementations of the strategies that I've just mentioned. Simple Stack is one of the more popular libraries, and I also know of Compass, with a K, and Alligator, which unfortunately both seem like they're not being maintained anymore. And of course, there's Enro, which I maintain and think it's the best in my own biased way. There's also Uber's Ribs and Square's Workflow, but those are pretty opinionated frameworks that go a little bit beyond just navigation and start really talking about your entire view layer architecture. If there's a library that I'm missing off here, please let me know. I'd love to hear about other approaches to navigation. So that's kind of the end of the content for this talk. In summary, navigation is a big and interesting topic. AndroidX Navigation is a thing, and you can make AndroidX Navigation work in a multi-module project. But unfortunately, AndroidX Navigation asks you to start thinking with the destination first, so thinking with those fragments first, and that causes some problems. I'm suggesting that you should try starting with the contract first instead. And you shouldn't be afraid of building a little navigation code yourself. You might even enjoy it. All right, that's all I've got. But before we begin questions, I'll just point out I've added my email there in case anybody's interested in chatting about navigation with me. Feel free to shoot me an email. I've also thrown up a link to Enro on GitHub in case anyone is interested in checking out a more complex implementation of some of the things that I'm talking about. All right. Does mentioning the fragment in navigation XML expose the UI information to the other application, even if I don't use the deep link feature? No, I mean, I wouldn't be 100% certain, but I'm pretty sure it doesn't. As you mentioned, we could use parseable as an archetype. Where should we keep that parseable class? Well, when I do this, I put all the parseable classes, those like navigation classes, down in a core module or like even a dedicated module just for navigation keys, so that all of the feature modules can depend down on that. This also means that you get a module that is just full of navigation keys only. So there's a few different approaches to that. Really, just whatever works for you, as long as it's in a place that other feature modules are able to depend on it. How do the solutions you mentioned work when supporting dynamic feature delivery? So AndroidX Navigation does provide some functionality to support dynamic feature delivery, but if you're going to use one of the other options that I mentioned, you will have to sort of support that yourself, particularly with if you're going to be like dynamically downloading those dynamic features. If you're just installing the dynamic features at like install time, I believe it should just work as per normal. To be fair, I'm not very experienced with dynamic feature delivery, so I'm sorry I can't give you a great answer there. Navigation component replaces the fragment. So we lose the state when the user is coming back. How can we handle this? Well, I'm not quite sure what you mean. Yeah, I don't think I can answer that one well, I'm afraid. I'm not quite, yeah, I'd have to know more about exactly the situation you're talking about, other than just using, on saved instance state, all of that. What's my thought on placing all navigation into a common module in a multi-module project? Well, I mean, that's generally the way that I approach things. I mean, it really depends on what you mean by all navigation. If you're just meaning the contracts for the navigation like I've discussed, then absolutely, that's the way that I do it. If you're talking about putting all of the fragments into a common module or something like that, I probably wouldn't do that. You lose some of the independent compilation and things like that. Can we implement a sub-navigation graph after landing on feature one? Oh, that one. Oh, sorry. Can we implement sub-navigation graph? E.g., after landing feature one, inside feature one, I want to go to feature one AAA. Yes, you can. In all of these solutions, you can certainly do that. It's just up to the specific implementation details how you do that. For example, Enro supports that. So if you want to see a more complex example of how that works, you could check out some of the source code there. Managing backstack with view pages, bottom navigation view, and up button is quite a mess when implemented using AndroidX Nav. I'm not sure if that's a question or just a statement. I mean, if that's a statement, I would probably agree. Does the navigation XML merge into one file during the compilation time like Android Benefit? No, it does not. So the navigation graphs, if you want them to be merged together, you can include other navigation graphs, but that's an explicit thing that you do. If an app's main screen can redirect to another 100 screens, fragment classes, is it possible to split the navigation file by grouping of features such as feature A, 20 screens, feature B, 20 screens, feature C, 30 screens? Yes and no. So the way that screen scoping, like navigation graph scoping, works with AndroidX Navigation is when you're kind of inside of a particular navigation graph, you can only really get to the actions that are inside that same navigation graph. So you could have a top-level navigation graph that included a feature A, feature B, and feature C sub-navigation graph, as long as feature A doesn't need to navigate to feature B, if that makes sense. So as long as that kind of top-level graph is managing pulling you out of A and into B. Which approach to navigation do you think is most practical in terms of testability? To be fair, I haven't done very much testing with AndroidX Navigation, but using safe-args, it's not so bad. Like particularly, you can safe-args are just data classes that you can look at them and check for them, check that they're being called in the right places, and of the custom solutions, again, the handwritten safe-args are quite nice. Like you could have a view model expose a live data of these navigation key types or something like that, and perform some view model tests and then check that those are going to be correct. AndroidX Navigation future with Jetpack Compose and Kotlin multi-platform coming. Yes, I'm not sure where the question is in there, but yeah, AndroidX Navigation, there is a Compose component coming out soon. And from the little amount of looking at it that I've done, it seems to be based primarily on like deep linking, basically. I haven't actually played with it in the multi-module project, though, so can't speak more to it. If we move feature-specific classes to the core module, does that not seem a bit wrong? As core is a bottom-level module that contains some classes featured. Yes, so that is, like, I can understand where that concern sort of comes from. But the way that I like to think about it is that the core module is, it's defining interfaces and things that are going to be implemented by the feature modules. It doesn't necessarily have to be completely standalone and have no bearing on the feature modules at all. And so the way that I look at those, like those navigator interfaces or those handwritten safeguards type classes, is that they're just contracts that are going to be fulfilled. They're not saying which feature module will fulfill it. They're just saying this will be fulfilled by some feature module. There's no other real way other than deep linking to sort of handle that. And I think we're almost basically running out of time here, so that might be all. Right. Thank you very much, everyone.